Hello, and welcome to another snow day. We are going to talk quickly about section 9.2, the end part. So in class on Friday, we talked about testing a claim using significance testing about a population proportion when our null and when our alternative hypothesis was less than or greater than. And today we're going to talk about two things. We're going to talk about a confidence interval to draw a conclusion about a two-sided test, which is when the alternative hypothesis is not equal to, and we're also going to compare these confidence intervals with two-sided tests. So we'll do both of these things. Okay, and we're going to go through this with an example. So I'm going to read this example. According to the Centers for Disease Control and Prevention, the CDC, website, 50% of high school students have never smoked a cigarette. Taeyeon wonders whether this national result holds true in his large urban high school. For his AP Statistics class project, Taeyeon surveys a simple random sample of 150 students from his school. He gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Taeyeon conclude? Give appropriate evidence to support your answer. So this is an example of a question you might see on the AP exam. They give you all the data you need, and they don't give you a significance level, but we need to give appropriate evidence to support our answer. So since we're comparing against some standard, this is where a significance test would come in. So let's get this going here. The first thing we have to do is set our null and alternative hypotheses. Well, your null is what you're comparing against. So my null is that p is 0.5. And my alternative, well, when we read this problem, we don't think that one thing or the other is true. We don't think more students have never smoked a cigarette or fewer students have ever smoked a cigarette. So the best Taeyeon's going to do is, well, he's going to see, is this number different at his high school? And different means not equal to. Okay, we need to clearly state what our variable of interest is. So P is the true proportion of students at Taeyeon's high school who have never smoked a cigarette. And then we need to set the significance level. Notice it's not given to us, but I'll just set our regular 5% significance level. Okay. Now we have to say what test we're going to use and check the conditions for the test. So the test we're going to use is a one-sample z-test for proportions. Again, because we're only concerned with one type of proportion. We're not comparing two proportions yet. We'll talk about that next chapter. But we just have one proportion. So one sample z-test. And again, we choose a z-test because our test statistic is a z-score. Okay. Now we're going to check our conditions. And our conditions are random, independent, and normal. So random, we know we're given a simple random sample of 150 students. And again, see how I'm being specific, not just checking. I tell them simple random sample of how many. Independent. Well, they say he goes to a large urban high school right up here. Large urban high school. So it seems reasonable if I take 150 times 10. We can just say it seems reasonable to assume that there are more than 1,500 students at his large high school. it is reasonable to assume that there are more than 1,500 students at his large high school. Okay, so random, independent, and my last condition is normal. And for our normal condition, what we're going to do is n times p and n times 1 minus p. And check that those are both bigger than 10. And n is 150, and p is 0.5, which is 75 students. N times 1 minus p is also 150 times 0.5, which is 75 students. So we met the normal condition, or we meet the normal condition. Okay, so we've done the first two things we need to do. We, again, stated our hypotheses, set the significance level, clearly stated what the parameter of interest was, and then we checked our conditions. Okay, so that's that for now. Now we have to actually compute our test statistic and find the p-value. So to do this, we need to know, well, what is p hat? He surveyed 90 out of 150. So p hat is 0.6. We need to know the mean of our sampling distribution, which is equal to the population parameter set in our null hypothesis. And we need to know the standard deviation, which is p times 1 minus p, and I know that 1 minus 0.5 is 0.5, divided by 150. Okay. And now I get my test statistic. Your test statistic is a z-score, and it's a z-score just like it always is. We take the sample value that we're looking at, we subtract the mean of the distribution, and we divide by the standard deviation of the distribution. And when you plug that into your calculator, you get 2.45. But now we need to see what the p-value is. To do this, let's take a look at the distribution we're looking at and how a two-sided test works with the p-value. So I'm going to take a look at this normal distribution. We're centered around 0.5, and our standard deviation was the square root of 0.5 times 0.5 over 150. Now, when we're doing a two-sided test, we look at our p-value, or our z-score, our test statistic, and we know it's going to be up here. So remember, the test statistic compared with 0.6. Okay, so if I'm going to write my z-scores down here in blue. So my z-score here, and z-scores at 0, and this is 2.45. But since it's a two-sided test, I need to look on the other side. So I need to look down here too. Two-sided test. So not only do we have to use our test statistic and look beyond it, but we also have to look at the opposite side. And over here, that would be negative 2.45. So when I calculate my p-value, it's going to be the area from this part and the area from this part. Since my standard normal curve is exactly symmetric, I can just find the area for this part and multiply by 2. I'll pick up that one. So to find my test statistic, let me just get a different color pen here. Do this. To find my test statistic, find this area, and we multiply by 2. So my p-value because this is, remember my table always gives the area to the left, so I want to use the negative one. My p-value will be 2 because it's a two-tailed times 0.0071, which is 0.0142. And now that we're done, we just have to make a decision. Okay, so what are we going to do? Well, we compare the p-value with alpha. Remember, alpha was 0.05. We see which one's bigger. Now it's really clear to me that alpha is bigger, so I reject. Since my p-value is smaller than alpha, we reject the null. And now we write a context-specific conclusion in terms of the alternative hypothesis. There is sufficient evidence to conclude that the true proportion of high school students who have never smoked a cigarette is different than 0.5. Okay, so that's how you do a two-sided test. And it's the same process. State the hypotheses, give what the parameter is, set the level of significance, say the name of the test you're using, and check your conditions. Do all the work out, so get the test statistic and the p-value, and then conclude by comparing the p-value with the significance level. But this isn't particularly telling, is it? I mean, when we were doing one-sided tests, at least we knew that the true population proportion was bigger or smaller. But this doesn't tell me anything. This just tells me it's probably not 0.5. And so here's a case where a confidence interval is actually more telling. Okay, and you can see here, I'm going to talk about why confidence intervals give more information. Well, a significance test lets us reject or fail to reject. But like I was saying before, when we reject, especially with a two-sided test, we're left wondering what the actual proportion might be. Is it bigger than? Is it smaller than? So a confidence interval might shed some light on this issue. So let's just quickly compute a confidence interval for this. And remember, p hat was 0.6, okay? Now the only thing that's a little different here is when you do your confidence interval, remember you don't actually know what the population proportion is. So with a confidence interval, we don't need to know the mean. Oops. We are doing the test statistic plus or minus your critical value, which again is a z-score here, times the square root, and we have to do p hat times 1 minus p hat over n, because again, when you're doing significance levels, or tests, sorry, you're assuming that the null hypothesis is true. But when you're doing confidence intervals, you don't know what p is. Okay, and we'll just say conditions met. We would have to normally check the conditions and go through all of that, but we did all that work already. So let's just quickly compute a confidence interval. And let's say we're doing 95% confidence. Okay, this works because, just a quick side note here, it's 1 minus alpha. And that's always going to be the confidence level that kind of corresponds with the two-sided test. We'll talk about that in a second. That corresponds with the two-sided test. Okay, and we know that p hat is 0.6. We know our critical value for 95% confidence interval is 1.96, and then we get our p hat times 1 minus p hat over n. And again, we have to use our value for p hat here because we don't know what p is. So when you compute all this with your calculator, I'll let you guys do the work. you get, this would be a good time to pause, by the way, and try it yourself. Make sure you can get it. You get 0.5216, and then about 0.6784. And then you would conclude, okay, 95% confident, confident that the true proportion of students who have never smoked a cigarette is between 0.5216 and 0.6784. And there are no associated units here because I'm talking about a proportion. Now you can see that this gives us a little more information. Not only did we reject last time, so we knew it was different than 0.5, but we know how it's different than 0.5. It's bigger than it, okay? And more specifically, it's just a little bit bigger, somewhere between 0.52 and 0.678, okay? So let's talk about a little more about, we're almost done here. Okay, so I'm just going to read this. There is a link between confidence intervals and two-sided tests. The 95% confidence interval gives an approximate range of p-nulls, meaning values here that are proportions, that would not be rejected by a two-sided test at the alpha equals 0.05 significance level. The link isn't perfect because the standard error, remember standard error is just when you use the standard deviation, okay, with p hat instead of p. It just means using what you have, using the sample value. Okay, the link isn't perfect because the standard error used for the confidence interval is based on the sample proportion, while the denominator of the test statistic is based on the value from the null hypothesis. So it's a little different. But let's just see how this works out, okay? Basically, what happens when you do this is if you get a value of p hat in your sample that falls in the fail to reject range, then your confidence interval will contain your null hypothesis level. Okay? If p hat falls in the fail to reject, oops, got a little ahead of myself there. The fail to reject range, the confidence interval will contain the value p from the null. Okay? Meaning that, remember what a confidence interval gives you. It gives you the range of plausible values. So if your confidence interval contains the null hypothesis, that means the null hypothesis is a plausible value for your true population proportion. So if you get a value for p hat, you can compute a confidence interval, and if that confidence interval contains the null, then you would fail to reject. So just listen to me say that one more time, okay? When you're doing a two-sided test, sometimes you can compute a confidence interval instead. And if you compute a confidence interval that contains the null, then that means the null is a plausible value, so you can fail to reject. Okay, this is the same beginning part. But conversely, if you get a value for p hat that falls in the reject range, when you compute a confidence interval, you don't end up containing the null. And here again is the null. Okay, so you would end up failing to reject. If p hat falls in the reject range, the confidence interval does not contain the value P from your null hypothesis. Okay, so what you can do again, instead of doing a two-sided test, you could just compute a confidence interval. And if your confidence interval does not contain the null, then that means your null is not a plausible value, meaning you can reject the null. Okay, so that's what that means. If HO is not in your confidence interval, you can reject it because it's not a plausible value. This only works for two-sided tests because that's how confidence intervals work. Okay, so that's it. You know how to compute a two-sided significance test, and you know how two-sided tests are linked with confidence intervals. If you compute the confidence interval and you do contain the null, then the null is plausible and you would fail to reject. If you compute a confidence interval and you do not contain the null, then the null is not plausible and you reject. So this is just a summary of everything we've done. So what you do, the state plan to conclude, and then how confidence intervals are tied with two-sided tests. Okay, and this is the homework. So these are just regular homework problems, and these are the multiple choice. When I see you again, I don't see you again until Wednesday, I'll collect the quiz. Okay. I spelled that wrong. I'll collect the quiz. I'll answer homework questions. And we'll talk about using your calculator to compute hypothesis or significance tests. Okay. And we'll also start touching on significance tests for the sample mean. And that's it. Enjoy the rest of your snow day, and I will hopefully see you in school tomorrow. Bye.